Okay, go ahead and try some of this homework on page 354. Start with number 1. They've told us y varies directly as x. And then they want us, well, they also tell us that y is equal to 6 when x is 15. And they want us to find y when x is 25. So there's 2 ways to do it. I'll do it both ways so you can make your own choice which way you do it. On a quiz or test, I will expect you to be able to do both ways. Okay, so there'll be one do it this way, one do it that way, and then probably one of your choice. So let's start with the model, what I call the model method. And that's this idea that if you told me y varies directly as k, then I can write down, well, directly as x, I'm sorry, then I can write down y is equal to mx. Okay, that's an equation that looks a lot like mx plus b, it just doesn't have the b, okay, no x-intercept. And I'm going to use that. I have y is 6, m I don't know, x is 15, and I'll solve for m. So 6 over 15, that gives me m is equal to, divide everything by 3, 2 over 5. So now I can write the model for this system, this situation, this data if it were data. So I'm going to write down the model. Y is equal to 2 over 5 times x. All I did was make my substitution for m. This is called the model. So anything else can be figured out using this model. So when they say find y when x is 25, I'll say y is equal to 2/5 times x 25, and I can figure this out pretty easily. 50 over 5, or y is equal to 10 is the answer. Now let me do it the other way on the next page. The next one is using a proportion method, okay? And if they tell me that they vary directly, I know they're going to be proportional. So I can use this method. And I know y equals 6 when x equals 15. So as long as I write proportions, in this case I'm always going to do y over x. Okay? That tells, I like to write down y over x so I know which variable I'm putting where, top or bottom. So in this case I've got 6 over 15 is equal to, they want us to find y, so that'll be on the top because y is always on the top here. And they told me x was 25, and I have set up a proportion. Now, I can cross multiply like I always would, but I like to reduce first. So I'm going to call this 2 over 5 is equal to y over 25. I just don't like when my numbers get too big. So this gives me 50 is equal to 5y when I do that cross multiply. And again, now I just divide by 5 and I get y equal 10 is the same answer as I got before, just using this other proportion method. Alright, the next type of problem you come across is something like number 9, where it's just asking you to find a geometric mean. So you have to know the definition, and what we say is, if we're going to call it x, our geometric mean, I like to say x goes high and low, okay, in the proportion, and 2 and 18 can go in either space. Okay, so as long as x is both high and low on either side of the equation, I've set up a geometric mean. I'll cross multiply. X squared, 36, x is 6. So 6 would be the geometric mean between 2 and 18. Okay, then I've got this problem on page 356, it's number 1, where they've given us a table in the book of values, water pressure versus depth, okay, and the question is at what depth, and I need a variable for depth, so I think we're going to go ahead and call that x, is what they used in the table. Would the pressure, which they use as y, be 147, and it's a kilopascal, okay, which is a consistent unit with what they already have in the table. Looking at the table, what's interesting to note is they've already given us the value of y over x. So the table tells me y over x is equal to 9.8, very consistently even. So every time they look at y over x, it's always 9.8. So I'm going to use that value. That's going to fit right in with when we write a model or when we use a proportion. Since it's already set up like a proportion, I'm going to go ahead and finish this problem as a proportion. So I'm going to say 9.8 would equal, sort of start a new equals. I don't like to have equal equals. 9.8 would equal, I'll change this into like colon or something. The y value, which was 147, and they want us to find the water depth x. So that allows me to set up this proportion. It's kind of like having 9.8 over 1 if you need that there. 9.8x equal 147. X would equal 147 over 9.8. And I'd throw that in my calculator and get an answer for that. Now, what unit, don't forget you have to have your units on these word problems. Go back and look at the chart. What was the unit for depth? It was meters. So make sure you have your unit here in your answer. And you got it. Okay, looking at page 360, we're starting to talk about variations that aren't direct. So we have the inverse, we have jointlies, different kinds of variation. Jointly is the same kind as direct, it's just that there's more than one variable. So that's what we're looking at here. They told us k was a constant, okay? And we call that the constant of proportionality. Then, okay, see if I can spell that. There we go. So they want us to write this in words, and I would simply say P varies jointly, because there's two variables, as S and T, okay? If it had just been one variable, I would have said P varies jointly as, P varies directly as S. But with the two, I'll just go ahead and say that varies jointly. All right, looking at number 7, I wanted to find something a little different. They're giving us the words H is directly proportional to T and inversely proportional to Z, and they want us to write this as an equation. So I'm simply going to say H, an equal sign for is. When they say directly proportional, you have to give that constant. So in this case, I'll choose K as a constant of proportionality. Because it's directly proportional to T, T is up on the numerator. Inversely proportional to Z puts Z in the bottom. And that's my answer. All right, for this problem on page 361, number 1, they're telling us that frequency varies inversely as the wavelength. So when I look at this, maybe I'll call that, it's really a lambda. Wavelength is a lambda. Frequency is indeed given by an F like that. Okay. So we have a frequency given by F, varies inversely as a wavelength given by this new Greek letter called a lambda. Okay, so when they do that though, I can write a model. The frequency varies, so I need a equals K, inversely as the wavelength lambda. Okay, now let's look at the data that they give us. The frequency is 1200, and they're giving that in kilohertz, when the wavelength is 250 meters. So I can use this, I can solve for K and come up with a nice model. K is equal to 1200 times 250. So let me calculate that. And I get K is 300,000. So you see where my little scratch work was over here. I'm going to erase that now. I could, and it doesn't seem to want to erase. So we'll just make room. So I have a new model. F is equal to 300,000 over the wavelength lambda. So the question though is, what would the frequency be when the wavelength is 400? So let's find the frequency. K never changes. The wavelength this time, 400. Okay, so I need to calculate this. So I'm going to cross out a couple of zeros, make it a little easier. I need to do 3,000 divided by 4 you'll get that answer. You'll need to put the kilohertz unit on the end of this, and that will finally give you the right answer.